So I thought I'd do a very quick impromptu video showing that I do actually make my own parts. Not the best machinist in the world, but I do have this little lathe here that, to be honest, can make most of the stuff that I want to do with a reasonable accuracy if you take your time. So this is a spacer reducer for the radius arm spherical bearing conversion I'm doing on the Esprit right now. It's stainless steel, probably 303 because it's actually machining quite well. I would have liked to have tried this in 7075 aluminium, but I just couldn't get anything in the right diameter, so I had some stainless left over from another job, and who doesn't like stainless steel? So here I am just roughing out the basic shape. Now I don't have a digital readout or anything on the lathe, and as I say, it's not the best machine. There's quite a lot of backlash in a cross slide. Another big problem is I'm kind of stuck on 700 RPM, which is not ideal for finishing. That's because the lathe is belt driven and it's a colossal pain to change the RPM. What I really want is a variable speed drive, but they're £400 to fit onto this machine and priorities. So I'd rather put that towards a better lathe, to be honest. I might look as if I'm messing about here, but mistakes really cost me, mainly in time. So as you can see, I'm really tight onto the bearing and I can't get it to fit. So I'm taking off as little as I dare, but not trusting this lathe too much. The problem with stainless is that it's actually physically hard, and fine cuts, especially with this RPM, the tool would rather rub or push away than actually take the metal off. So in the end, I resorted to using a file to get a really nice push fit on the bearing. So now I'm just turning down the chamfer with the compound slide, cutting in both directions. So again, it looks like I'm faffing about a bit, but I've had to make about 20 of these now, and I only get 2 to 3 hours in between everything else to make them, so yeah, mistakes can be pretty costly. So I generally revert back to measure twice and cutting once as often as I can. I also don't have the space to keep a lot of stock here, so I usually buy to order, which again, if you run out of material, it's just going to cost you time and money. Right, a quick face off to get the components to the right length. 2 of these hold a spherical joint, so there must be a gap in between them when assembled, or the bearing is just going to rattle between the pair. I'm trying to get that gap as small as possible. It is kind of my curse that I just cannot lie to myself, and my work has to be the best I can do, or I just scrap it and start over. It really is a curse. Again, a digital readout positioning here would be great. Okay, now for the fun bit, which is parting off. I'm just using the dial indicator to make sure that the parting tool is perpendicular. Once that's done, I just pile in. You have to be brave here and use a lot of pressure to make the tool work. As you can see, I'm using cutting lubricant here and not coolant. It does produce a lot of smoke, but I have a series of fans that are extracting that. And there you go, the workpiece is only 48 degrees and the part is 67 degrees, which is really cool. So if you're parting off like this, a lubricant works really well. So this is what this is for here. We've got the radius arm bolt, and that spacer goes down there to increase this diameter here. And then the bearing slides over there. It should, a little bit of a wiggle because it's quite tight. It goes into there, and then that goes onto there like that, and it captivates the whole thing. So this is the fruits of my labour, as it were, and this is what's been keeping me busy for the last couple of nights. All of this is for the new Esprit suspension, and there's a video on that coming very soon. I hope this has been of some interest, and as time goes by, it'd be great to expand my capabilities here. But for the time being, that's all, and as always, thanks for watching.